Hello, this is Yashveen. In this video, I'll be solving 062041 May-June 2018 Chemistry. Starting with question number 1, substances can be classified as elements, compounds, or mixtures. A. What is meant by the term compound? So here you're supposed to be starting with writing the definition of compound. B. Mixtures can be separated by physical processes. A sequence of physical processes can be used to separate common salt from a mixture containing sand and common salt only. Give the order and correct scientific term for the physical processes used to separate the common salt from mixture. Right, since this is a mixture of two solids, the only two applicable processes that for separation of mixture of two solids are either it has to be based on the difference in their magnetic properties, and for that to be applicable, one of the two substances or all of the substances has to be, one of them has to be having magnetic properties. But since here neither sand nor salt has that, so we'll move on to the second method, which is different in solubilities. So as you can see over here, salt is soluble in water but sand is not. So that is how we're going to be separating them based on the difference in their solubilities. So first step is dissolving the mixture in water. And then the second step is filtering out the sand, so you're left with the residue of salt. So the remaining residue contains the salt solution, and then you can crystallize it to obtain that salt. The boiling points of 4 different alcohols A, B, C, D are shown. So as you can see, the boiling points are increasing from A to D. C. A student suggested that the apparatus shown could be used to separate the mixture of alcohols. So we have an apparatus for separating all of the mixture of these alcohols. 1. Apparatus X needs to have cold water flowing through it. Draw an arrow on the diagram to show where the cold water enters the apparatus X. Alright, so we have the condensation. We have the condenser labeled here as apparatus X, and the water goes in through the lower inlet. Name the apparatus X. So the apparatus X here is condenser. 2. Part of the fractionating column is missing. This means that the experiment will not work. Draw on the diagram the part of the fractionating column which is missing. Alright, so basically what is happening over here is we heat the mixture of alcohols and up to the point of their boiling points. So the lowest boiling point over here is 56. That means the first alcohol that vaporizes is 56, and then it is converted from its vapor form into its liquid form in the condenser over here. However, for it to be converted into its liquid form, it has to pass through this region from the fractionating column and through the condenser. But if this column is left open in the way that it is shown over here, the gas could escape from the apparatus. So that means we need to add a stopper over here to prevent the gas from escaping. Explain why the experiment will not work with this part of the fractionating column missing. Right? So we write the explanation over here. Three, suggest why a Bunsen burner is not used to heat the flask. Because the mixture contains alcohols which are flammable. To keep away from any risk of igniting a fire, a Bunsen burner is not used. 4. A hot water bath cannot be used to separate mixtures, to separate alcohols. C and D, explain why that is so. Right, so as you can see over here, C and D have a boiling points of 122 and 160. and these are above the boiling point of water, which is 100 degrees Celsius. So if we heated water above 100 degrees Celsius, it would evaporate itself, and it won't be able to heat this mixture of C and D anymore. So that is why we cannot use water over here. Two flerovium, atomic number 114, was first made in research laboratories in 1998. A flerovium was made by bombarding atoms of plutonium, atomic number 94, with atoms of element Z. The nucleus of one atom of plutonium combined with the nucleus of one atom of element Z. This formed the nucleus of one atom of flerovium, suggests the identity of element Z. Alright, if the nuclei of Z and plutonium combined, that means their atomic numbers combined to give the atomic number of the product, which is 114. Since we know the atomic number of plutonium over here, which is 94, we can work out the atomic number of Z, which would be 114 minus 94. So this gives the atomic number of Z as 20. And from the periodic table, we can come to know that this is calcium with atomic number 20. B, in which period of the periodic table is flerovium? So flerovium is found below lead in group 4, which places it in period 7. Predict the number of outer electrons in an atom of flerovium. Since it's found in group 4, it would have 4 electrons in its outer shell. The two isotopes of flerovium are 286 and 289 flerovium. The nuclei of both of these isotopes are unstable and emit energy when they split up. 1. State the term used to describe isotopes with unstable nuclei. So these are called. Complete the table to show the number of protons, neutrons, and electrons in the atoms of isotopes shown. Since the atomic number does not change, number of protons and electrons remains the same because this is a neutral atom, or these are two neutral isotopes. The atomic number from the periodic table is 114, and we can calculate the number of neutrons by subtracting the number of protons from the mass number of each isotope. So 286 minus 114 gives 172. Similarly, 289 minus 114 gives 175. Only a relatively small number of atoms of flerovium have been made in the laboratory, and the properties of flerovium have not yet been investigated. It has been suggested that flerovium is a typical metal. 1. Suggest two physical properties of flerovium. Right, so linking physical properties with metals, one of them could be that it has a high melting point and that it conducts electricity. 2. Suggest one chemical property of flerovium oxide. Alright, so flerovium oxide, when reacting or showing its chemical properties, acts as a basic oxide. 3. This question is about iron. 3 of the raw metals added to a blast furnace used to extract iron from hematite are coke, hematite, and limestone. Name one other raw material added to the furnace. So we also need air over here. B. A series of reactions occurs in a blast furnace during the extraction of iron from hematite. Describe these reactions. Include one chemical equation for the reduction of hematite and one chemical equation for the formation of slag. Alright, so first off, the reaction starts with converting this coke into carbon dioxide to heat the furnace. The next step is that this similarly coke reduces carbon dioxide to carbon monoxide. And the third step is that this carbon reduces iron oxide or hematite. So here I'm going to be writing the equation for the reduction of hematite. And then this gives the products as iron as an element itself, as well as carbon dioxide. And now the limestone, which is added over here, comes to use for the removal of impurities. But first it has to be broken down to form calcium oxide or lime. It's used to remove silica, which is the actual impurity we're supposed to be removing over here. Alright, this is quite enough. And now I'll write the equation for this step. So it breaks down to calcium oxide or lime as well as carbon dioxide. And then the last step is that this lime product over here reacts with the impurities to form this slag. Alright, so silicon oxide or silica over here is the main impurity which we are removing, and this forms calcium silicate. It forms in the state of liquid and forms a layer of slag. C. The iron extracted from hematite using a blast furnace is impure. Identify the main impurity in this iron and explain how it is removed in the steel making process. So the main impurity over here is carbon, and it moves out of the furnace in the form of carbon dioxide. But we have to mention how it is converted to carbon dioxide because we have 3 marks over here. That means 2 marks for the removal and 1 mark for the name of impurity. So oxygen is blown into the furnace into molten iron, which converts the carbon impurity into carbon dioxide, which is a gas, and so carbon dioxide leaves the furnace in the form of gas. This question is about masses, volumes, and moles. A. Which term is defined by the following statement? Right. The average mass of naturally occurring atoms of an element on a scale where carbon-12 has a mass of exactly 12 units. This is relative atomic mass. B. Butane has a molecular mass of 58. Potassium fluoride has a relative formula mass of 58. Explain why the term relative molecular mass can be used for butane but cannot be used for potassium fluoride. Right, so molecular mass is used for the molecules which are formed by covalent bonding or are covalent molecules. However, relative formula mass is used for the compounds which are made up of ions, which, as you can see over here, has this compound has the potassium ions and fluoride ions, but this one over here is a covalent compound, and so it has the name. It is defined by molecular mass. And the reason that I'm writing both of the points is that is because we have 2 points, so we have to mention at least 2 points. Sorry, we have 2 marks for which we need to mention at least 2 points. C. A 0.095 grams sample of gaseous element Y occupies 60 centimeter cube at room temperature and pressure. Determine the number of moles of element Y in 60 centimeter cube. Right. So we have the volume of the gas, and to calculate the moles of a gas, we have the formula volume over molar volume. Right. But first, we need to convert this centimeter cube into dm cube, which would give the volume of Y as 0.06 dm cube. And so we have the calculation as 0.06 divided by the molar volume, which is 24, and this gives the answer as 2.5 into 10 to the power of -3 moles of element Y. Calculate the relative molecular mass of element Y and hence suggest the identity of element Y. Right. So we have the formula moles is equal to mass over molar mass, and from here we can derive the formula of molar mass, which would be equal to mass divided by number of moles. And so we have mass from the question 0.095 divided by the moles calculated in the previous section, which was 2.5 into 10 to the power of -5, gives the answer of molecular mass as 38. Now we're supposed to be identifying the element Y. Now keep in mind over here that this is not relative atomic mass. This is molecular mass of a single element, which means this element is composed of is a diatomic molecule, because this is a gaseous element, and gaseous element alone itself exists as diatomic molecule. So over here I'm going to divide 38 by 2 because we have 2 atoms in a single molecule, which gives the answer as 19. Now this is the relative atomic mass of element Y. If you check out the periodic table, you would see that fluorine has the relative atomic mass 19, and so element Y is fluorine. A 1.68 gram sample of phosphorus was burned and formed 3.87 gram of an oxide of phosphorus. Calculate the empirical formula of this oxide of phosphorus. To calculate the empirical formula of any compound, you need to have the mass or percentage composition of all of the elements in that compound. So I'm going to be using the concept that total mass of all reactants is equal to total mass of all the products, and that means since we have mass of phosphorus, we only need to calculate the mass of oxygen, which can be calculated by subtracting the mass of phosphorus from the mass of product. And so this gives the mass of oxygen as 2.19. So I'll start by writing the symbols of the elements in the compound. Then we have the mass over here, followed by calculating their moles. So I'll divide the mass with their relative atomic mass, which is 31 for phosphorus and 16 for oxygen. And this gives the answers as 0.0542 and 0.136, three significant figures over here. And then I'll calculate the ratio by dividing both of the values with the least value, which is 0.0542 over here. So this gives the answer as 1:2.5, but we want whole numbers, so I'll multiply this whole ratio with 2. So this gives the answer as the ratio of phosphorus to oxygen as 2:5. So we have the formula of phosphorus oxide over here. Another oxide of phosphorus has the empirical formula P2O3. One molecule of this oxide of phosphorus contains 4 atoms of phosphorus. Alright, so the simplest formula is this one. However, one molecule of this phosphorus contains 4 atoms, which is twice as 2. So if the phosphorus atoms are doubled, that means number of oxygen atoms would also be increased by a factor 2. So that means 3 2s are 6. We have the molecular formula of this compound now. Calculate the mass of 1 mole of this oxide of phosphorus. So simply multiply 4, which is the number of atoms of phosphorus, with its relative atomic mass, which is 31, and add the mass of oxygen as well. So we have 6 into its relative atomic mass, which is 16, and this gives the answer as 220 grams. 5a. The table gives some chemical properties of transition elements and their compounds, and of group 1 elements and their compounds. 1. What is meant by the term catalyst? Alright, so we are supposed to be writing the definition of catalyst, which is to give one other chemical property shown by transition elements which is not shown by the group 1 elements. So this is their variable oxidation states. B. Give two physical properties shown by transition elements which are not shown by group 1 element. Right? So they have higher densities and they have higher melting points as well. See, the energy level diagram shows the energy profile for the reaction between zinc and dilute sulfuric acid. 1. Complete the diagram by adding the formulae of the products. Include state symbols. Since this is a reaction between a metal and an acid, we get a salt as well as hydrogen gas. So the salt is formed in the form of aqueous solution, since it's still in the solution. So it's in the aqueous form, as well as hydrogen, which forms in gaseous state. 2. Draw an arrow on the diagram to represent the activation energy. So right, this is supposed to be leveled with the energy of reactants and pointing upwards to the top of the hump over here. 3. Is the reaction endothermic or exothermic? Explain your answer. Since the products have less energy compared to the reactants, this is an exothermic reaction. D. The reaction between zinc and dilute sulfuric acid can be catalyzed by the addition of aqueous copper sulfate. Alright, on the diagram, add the energy profile for the catalyst reaction. So the reaction stays the same, however, the activation energy decreases. So as you can see over here, the height of the arrow would be less. You do not need to indicate this arrow. E. A student electrolyzes aqueous copper sulfate using the apparatus shown. Oxygen gas forms at the positive electrode. 1. Write an ionic equation for the reaction at the negative electrode, which is cathode. Include state symbols. Alright, so negative electrode means it would attract the positive ions. So the positive ions in aqueous copper sulfate are hydrogen and copper. But since copper is less reactive than hydrogen, copper ions deposit at the cathode. Alright, as you can see over here, copper has an oxidation state of 2+. So the ions have the oxidation state of 2+. And for writing these ionic equations, you need to see, is the ion electron deficient or does it have more than it needs? So you can see over here, this has a positive charge, which means it needs more electrons. The number of protons in this ion are greater than number of electrons. So you need to cancel out this charge. You need to convert this ion into a neutral atom. So how many electrons do you need to add to convert this oxidation state into 0? You need to add 2 electrons to cancel out this 2+ charge, to convert this copper ion into copper metal, and you're supposed to be including the state symbol. Since this is the metal form, it forms in a state of solid, and ions are in the form of aqueous solution. 2. Describe what the student observes at the negative electrode. Alright, so the negative electrode has copper ions depositing over itself and copper metal forming, which is a solid. So a solid forms on it. 3. Give two other observations which the student makes during the electrolysis. Right. Since the solution has copper sulfate, it would initially have the color blue, which is due to copper 2 plus ions. But as the reaction proceeds, these ions get converted to copper metal, and that means the ions no longer remains, and due to which the blue color of the solution also fades. So that is going to be one of the observations. And the second observation is at the anode, which is positive the positive electrode over here. We have oxygen gas forming as one of the as the only product at anode, and that means bubbles form over here at anode. 4. What difference would the student observe at the positive electrode if the aqueous copper sulfate were replaced by concentrated aqueous copper chloride? Alright. I'd like to break this down into the ions that we have. So the negative ion over here is sulfate ion, a non-metal ion. And then here we have chloride ion. Since we're talking about the positive electrode which would only attract negative ion, I have mentioned the two possibilities. So the first case we had the negative ions as sulfate ion as well as hydroxide ion. In this case, whenever you have hydroxide ions and a non-metal ion, oxygen always forms at the positive electrode. However, if you have hydroxide ions as well as a halide ion, this halide ion gets deposited at the positive electrode, and that means if instead of copper sulfate, copper chloride, concentrated aqueous copper chloride was used, you'd get green bubbles of chlorine gas instead of the colorless oxygen which formed in the previous case. Six, the table shows the structures of four hydrocarbons. A. Why are the compounds PQRS known as hydrocarbons? So we're supposed to be writing the definition of hydrocarbon. B. Compound P is saturated. What is meant by the term saturated? That means it has all carbon to carbon single bonds. C. Compound P undergoes a substitution reaction with chlorine, right? So it has, alright, so this goes. Ethane undergoes substitution reaction with chlorine. 1. What is meant by the term substitution reaction? Two, state a condition required for this reaction to occur. Alright, so you need to have ultraviolet light for a substitution reaction with chlorine. 3. Write a chemical equation for this reaction. So a chlorine atom over here substitutes for hydrogen, and the other product is hydrogen chloride. D. Compound R undergoes an addition reaction with bromine. Alright, so R over here is an alkene, which means the double bonds break up. One double bond breaks up. Why is this reaction an addition reaction? Multiple reactants give only one product. 2. A compound containing bromine is formed in this reaction. Draw the structure of this compound, show all of the atoms and all of the bonds. Alright, so this double bond opens up and one bromine atom goes to each of the 2 carbon atoms in this chain. So we have 3 carbon atoms, 6 hydrogen atoms, and 2 bromine atoms. This is H over here in case it's not clear enough for you. E. Draw the structure of an unbranched isomer of compound S. Alright, let's see S. S over here also is an alkene, and we can shift the double bond over here from the first position to the second one. Show all of the atoms and all of the bonds. Name this unbranched isomer of S. Alright, so we have this is carbon. We have the double bond in the second position, and then all of the rest of the hydrogen atoms. Make sure you have the same number of carbon and the same number of hydrogen atoms, and the valencies of carbon and hydrogen are balanced. That is, carbon forms 4 bonds in total. Since we have 4 carbon atoms, this is going to be butene, but this is an isomer, and as it is in the second place, this is going to be butene. As the double bond is in second place, this is going to be butene. F compound Q undergoes polymerization. 1. Name the polymer formed. So F is ethene, and it forms the polymer polyethene. 2. Complete the chemical equation to show the polymerization of compound Q. So the double bonds over here open up to give one single bond between the backbone chain. So they open up to give a single bond, and then I'll write this N over here. G. Amino acids undergo polymerization to form proteins. Part of a protein molecule with the linkages missing is shown. Draw the linkages on the diagram and show all of the atoms and all of the bonds. Right, so each amino acid has one amine group on its side, and on the other side it has a carboxylic acid group. And by polymerization, a water molecule forms, and that leaves with one hydrogen, and this hydroxide ion removed over here. So that means if we already have the amine group over here, the second group over here is going to be the carboxylic acid group, but it is no longer that group. However, it reacts with the nitrogen of the next amino acid. And then once again we have carbon over here, and then nitrogen atom over here, and these are the amide linkages. H. The structure shows an ester. Write the word equation for a reaction which could be used to make this ester. Alright, so for forming esters, for drawing them, we always draw the structure of the acid first. Right, so to draw, we draw the acid first and then the alcohol. However, on the contrary side, we have for naming them, we name the alcohol first, followed by the acid. If this is the drawing of the ester, that means this part over here, the second part, is going to be the alcohol, and this part over here has come from the acid. So as you can see over here, we have 1, 2, 3, and 4 carbon atoms, which means it has to have come from butanoic acid, and this structure only has 2 carbon atoms, which means it has come from ethanol. Now let's proceed to naming them. We name with starting with the name of the alcohol first. Right, so we have butanoic acid reacting with ethanol, forming the ester ethyl butanoate, as well as water, which is the byproduct. Alright, this is it. We are done with this paper. Thank you for watching.